right, let's see. What's the integration of sine?
Negative cosine.
So you're literally going to integrate 2x minus cosine x, yes?
Yes.
Keep in mind a couple things. Notice that your answers are having pi and pi squared and things like that. You're going to have answers like that. There's nothing that says that you can't. Cosine of pi. Thank you. Cosine of 0. Good job. 2 pi plus 1 makes us 2 pi plus 2. Did you get out 2 pi plus 2? Good. Have we finished off the second one?
We didn't do definite.
We just did yesterday, we just did indefinite.
Yeah, we just did indefinite.
So for the second one, what's the integration of secant tangent again? Secant theta evaluated from 0 to pi over 3. Which is the secant of pi over 3 minus the secant of 0. I always think of secant in terms of cosine, so the cosine of pi over 3 is 1/2. So the secant of pi over 3 is 2. Cosine of 0 is 1, so the secant of 0 is 1. The answer is literally just 1. Again, this is remembering that the integration of secant tangent is just plain old secant because the derivative of secant is secant tangent. Alright. Let's talk about number 3. What's different with number 3? There's a 2 sitting with that, isn't there?
Yes.
It's not a plain old x. It's got a 2 sitting in front of that x. Because there's a 2 sitting in front of that x, you have to do what?
Use
You have to do more work. You have to use u substitution. Let u equal 2x, because that's what's inside the function. The sign is the function. Inside the function has to be a plain old x. It's not a plain old x, and you got to do u sub. So let u equal 2x. Then du is 2 dx. Do I have that too? No. So divided by 2. So du over 2 equals dx. So the integration of the sine of u du over 2, or most of you can go straight shot and just go 1/2 sine of u du. What's the integration of sine?
negative cosine.
So I have 1/2 negative cosine of u plus c. Everyone agree? Wait, what? Oh, I do have to plug in, but what else, Jason? Do parentheses matter here?
Yes.
Well, they matter a great deal here, because right now that says 1/2 minus cosine of u. It's not 1/2 minus cosine of u, it is 1/2 times negative cosine u, which makes this negative 1/2, the cosine. I'm going to plug back in u was 2x, plus c. Now, somebody in my last class asked me, could we write this as the negative cosine of 2x over 2 plus c? And the answer is yes. That's fine. I don't care how you write that one. Either one is valid. So let's talk about the next one, number 4. It says secant 2x tangent 2x. It says secant 2x tangent 2x. Now, I didn't actually put the parentheses in there, but could you put them in there?
Yes.
Where would they go around?
The 2x.
The 2x. They're not in there, but they would go around the 2x. So it's the secant of 2x times the tangent of 2x. What do you have to use? It is not product rule, because product rule says something in the derivative.
Just use them.
Okay? So it's not product rule, because product rule means the derivative. Merlot, what do you say?
Just use them.
What could I use them with?
2x.
Oh. Because it's not a plain old X. If it's not a plain old X, I guarantee you have to use your substitution. If it is not a plain old X, sitting after that trig function, so sitting after where the angle is, sitting after sine, cosine, tangent, cosecant, secant, cotangent, if it's not a plain old X, you're going to use your sub. Guaranteed. So let u equal 2x, then du is 2 dx, which I don't have the 2. So that says 1/2. I'm just pulling that out. Secant u, tangent u. You'll notice that both of these 2x's are replaced with u's. Notice that? Both of those 2x's are replaced with u's. John, can I integrate secant u, tangent u? Into what? Yep. So 1/2 secant u plus c. And my last step, because it's an indefinite integral, because it has a plus c, is you have to plug back in your x. And my x in this case was 2x. Plug back in my u, I should say. Alright, we have 2 more to do. Now the next one that we're going to do is number 5. And number 5, we are literally going to do this 2 ways. Okay? Here we go. First way. What do you think I could do for this one?
Split it up.
Okay. I've heard a couple things. If I bring it up, does it help me to bring up sine squared? That would be sine to the -2. Not really. What I did here is split it up, and I saw something go like this. Means I'm thinking that I mean 2 different things, right? Because reality is that cosine's fine, but sine can be written as sine times sine. That's literally what sine squared means. And because this is multiplication, I can write this as cosine over sine times 1 over sine. That's the same thing as sine over sine squared. You okay with that so far? Well, how else could I write cosine over sine? No. Cotangent. Cosecant. Because cosine over sine is cotangent, 1 over sine is cosecant, not cotangent times cosecant. And let's go with Abby. Cotangent, cosecant, the integration of that something I know? Yeah. What has cotangent and cosecant as its derivative? That's what we're thinking. Ooh, not cotangent. Cosecant. But the problem is that the derivative of cosecant is negative cosecant cotangent, so the integration needs to be negative. Here's my first way of doing this one. Totally agree? Agree with the answer? I'm good. Everyone okay with that? But let's say you didn't see that. Let's say you didn't recognize that I could split this up and do it this way. I want you to write down the same problem again. You can do it right below. But in this case, I'm actually going to rewrite sine squared theta again, but I'm not going to write it as sine times sine. I am going to write it as the quantity sine theta, the quantity squared. It's the exact same thing. It means the exact same thing. And sine squared theta and sine theta quantity squared are the exact same things. But I wrote it like this for a reason. Because when you see this, what do you think?
Change bring it
Oh. Omar, what'd you say?
You can use U sub.
Why can I use U sub?
Because now you have a function.
I have a quantity squared, don't I?
Yes.
If I have a quantity squared, which means there's something inside that parentheses, can I do U substitution? Well, let's see if I can or not. So we're going to say let U equal. What am I letting U equal?
Sine theta.
Sine theta, because that's what's inside that parentheses. If that's true, then what's du?
Negative cosine.
Sine times sine is cosine, so it's cosine theta d theta. I have a question. Do you have cosine theta d theta? Oh. That means I can use your substitution. Because this whole piece is sitting right here. So that whole thing becomes du. Where is the sine sitting? On the what? Bottom. So it's 1 over u squared. Can I integrate 1 over u squared? Yep. I'm going to rewrite 1 over u squared as u to the negative 2 power. By the way, those of you that said, oh, you should bring up that sign, that quantity squared, bring it to the top, make it quantity to the negative 2 power. There it is. I didn't use substitution so earlier. It doesn't matter, it's the same thing. You can integrate this. Andrea, integrate u to the negative 1, or u to the negative 2 for me, please. Fabulous. I'm going to rewrite this as negative 1 over u plus c. Because it's not a definite interval, it doesn't have numbers on it, I have to plug back in. What was u again? Sine theta. I have a question. Can I rewrite 1 over sine theta as something? Can't I rewrite it as negative cosecant theta? Plus c. Hey, isn't this the exact same answer that I got before? This one took more steps. Yes. This one was a lot longer. But, if you didn't see the other one, use substitution work. Do I care which steps you do it to? Sometimes you have to do use substitution, sometimes you don't. Alright. Nope. Oh, it's going to say integrate. It will literally just say integrate, and here's 6 problems to integrate. So you need to figure out if you're using u sub, you're splitting up, whatever you're doing too. Alright, let's talk about number 6. Number 6, can I straight integrate this?
No.
Alright. Can I, well then what could I do? Bridget. So let me rewrite this in terms of exactly what she said. And she said, could I rewrite this as cosine t quantity cubed? And the answer is yes. That's what I would do too. Huh. So, Violet, what do you think you want to do next? Can you integrate it the way it is right now? Okay. So, Gabe, what do you want to do? Okay. So Gabe says he wants to let u equal cosine. Why are you saying let u equal cosine t? I agree with that, by the way. Totally agree. Why did you say that one? Because he recognized if I say let u equal cosine, I have its derivative sitting there. You notice that? I take the derivative of cosine, I have the derivative sitting there. And by the way, the cosine is what's inside that parentheses. That's the other big piece. It's either what you have the derivative of, or what's inside the parentheses. Those are the 2 big key things you can ask yourself. What do I have the derivative of sitting there? I have the derivative of cosine. Or what's inside the parentheses? Because inside the parentheses, that's the most complicated piece. give me someone to draw a cosine? Thank you. Do I have the negative sign t dt? I have sine, so I just need to divide by -1. Brady, what else do I have to do? Am I ready to plug in? Let me ask you that. Am I ready to write my integration? Emma, what do I need to do? Abby, what do I need to do? Thank you. Abby's like, I gotta plug in U0 and U5 2. I gotta figure out what those values are. That's really important. U of 0 is the cosine of 0, which is 1. U of pi over 2 is the cosine of pi over 2, which is 0. Now, I can write my integration. I have the integration of from 1 to 0 of u cubed du over -1. So we're okay so far over there. Yes. I would. I'm going to do one step before. I'm going to pull this negative outside, the -1 on the outside. And then I'm going to do exactly what Bridget just said. Bridget said, can't you flip it to make it in a nice order? I like it to go in order, so I'm going to flip it, goes 0 to 1. When I flip it, it goes negative on the outside. But there's already a negative on the outside, which makes it just, the whole thing just positive. Now here is what, and I'm grading your test, and I'm seeing this over and 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 over again. Do not go back to x's. 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 These limits match u. The whole point of doing this is it makes it a lot easier. What's the integration of u cubed?
U4 D4.
This I can do really easily. One to the 4th over 4 minus 0 to the 4th over 4. That's the whole point of changing those limits. They match the u's, and it makes it a heck of a lot easier. 1 to the 4th over 4 is just 1/4. 0. 1/4 minus 0 is 1/4. A reminder yet again, when you are doing u substitution, if you have limits on your integration sign, you change those limits and you do not go back to x's. Never go back to the x's if you're doing u substitution with limits. Okay?